All right, let's get into it. Today, we're going to crack the code on a type of algebra problem that, let's be honest, can be super intimidating, word problems. Specifically, the ones that deal with sums and differences. By the end of this, you'll know exactly how to translate them and solve them. Let's do this. So, have you ever stared at a math problem that's disguised as a paragraph and just felt your brain completely freeze up? If you have, you are not alone. That's a totally normal reaction. But what if I told you there's a simple trick to make them way easier? Here's the secret. You have to stop seeing them as these scary stories and start seeing them for what they really are, a code. And in this explainer, we're going to become code breakers. We're going to learn how to translate all those words directly into the simple language of math. Now, every good code breaker needs a translation guide, a key to decipher the message. Well, this is ours. We're going to focus on the keywords that unlock these problems every single time. First up is sum. Whenever you see words like total, combined, together, or in all, that's your big signal for addition. It's basically the problem's way of shouting, hey, add these things up. And its counterpart, of course, is difference. This is your signal for subtraction. So phrases like more than, less than, or the super obvious difference between are all just clues telling you to set up a subtraction equation. And here's exactly how those keywords translate into actual algebra. For sum, you get x plus y equals the total. For difference, it becomes x minus y equals the difference. You know, we usually make x the bigger number here. It just helps keep the math a little more straightforward. Okay, now here is where the magic really happens. These two equations, they're designed to work together. When you have both a sum times and a difference equation, you can use this incredibly powerful shortcut called the elimination method. You just stack the equations and add them straight down. And that positive y and the negative y, they completely cancel each other out. It's an awesome hack. So let's put our code-breaking skills into action. We're going to follow a super simple two-step process that you can use every single time. Ready? It's just translate, then solve. That's it. All right, here's our first mission. This is a classic, straight-to-the-point problem. The sum of two numbers is 20. Their difference is 4. Let's break the code. Okay, step 1 is translation. We see that keyword sum, so we immediately write x plus y equals 20. Then we see the keyword difference, and we write x minus y equals 4. And just look at that. That messy English paragraph is now 2 clean, simple lines of algebra. So much better. And now for step 2, solve. We use our elimination hack and add those two equations together. The plus y and the minus y cancel right out, leaving us with 2x equals 24. From there, it's easy, right? Just divide by 2 and x equals 12. To find y, we just plug that 12 back into our first equation, and that gives us y equals 8. And there you have it. The two mystery numbers are 12 and 8. We cracked the code, all thanks to our two-step process. Okay, let's try a slightly different version. Here, the language is a little less direct. Tom is 5 years older than Jerry. Together, their ages add up to 21. It's the same idea, really, just wearing a different disguise. So the translation here is a bit different. Together, their ages add up to 21. That's our sum equation. T plus j equals 21. But then Tom is 5 years older than Jerry gives us t times equals j plus 5. Now, since we know exactly what t equals, this setup is absolutely perfect for the substitution method. We just replace the t in the first equation with, j plus 5 and solve from there, just like you see here. And after we simplify and solve for j, we find our answer. Jerry is 8 years old. The big takeaway here is you gotta let the phrasing of the problem guide your method. Sometimes it's gonna be elimination, sometimes it's substitution. Let's level up one more time. This one throws in a little bit of geometry, which, by the way, word problems love to do. It says the perimeter of a rectangle is 30 centimeters. The length is twice the width. The key here is remembering the formula for perimeter. 2L plus 2W equals 30. That's our first equation. The second one comes from that phrase, length is twice the width, so L equals 2W. And just like the last problem, this is a perfect setup for substitution. We swap out L for 2W, and the rest is just straightforward algebra. So solving that equation gives us a width of 5 centimeters. And since the length is twice that, it has to be 10 centimeters. And there are our dimensions. See? It's the exact same process, translate and solve. We just had to pull in a geometry formula first. Now, before we wrap up, every code has its traps, right? And these word problems are no different. So let's look at a couple of common pitfalls just so you can avoid them. Two of the biggest mistakes are really easy to make. First, mixing up the order in subtraction. And we're going to dig into that one in just a second. And second, just forgetting the 2's in the perimeter formula. You got to remember, perimeter is 2 lengths plus 2 widths. Okay, pay really close attention to this one. The phrasing is super subtle, but it changes everything. The difference between x and y translates to x minus y. Simple. But the phrase x less than y actually means you start with y and take x away from it. So it becomes y minus x. Seriously, reading carefully is half the battle. So why does any of this even matter? I mean, when are you actually going to use this stuff? Well, the answer might be a lot closer than you think. The thing to remember is that this isn't just some textbook exercise. Professionals like land surveyors use these exact same systems of equations all the time. They might get 2 simple facts, like, say, a total boundary and the relationship between length and width. And from just that, they can accurately map out an entire piece of land. And that brings us to the end. Hopefully you can see now that these problems aren't just about algebra. They're really a way of thinking logically about the world. So I'll leave you with this question to chew on. Look around you. What 2 facts about your life, your budget, your schedule, your goals, could you turn into a system of equations? You might be pretty surprised by what you can solve.